Hey, you know what? Let's try part two. We want to do something now where we actually iterate through these values and try to find the largest one. So we're going to do this. This is how we would go about it. We've got our values, our particles stored in memory. We iterate through those values, but here's what we need to do. We need to keep track of what is the largest value that we've found so far. Right now we're just going to search for the largest particle. Okay, so one thing that we should do is at birth, the orange particle should store a kind of initializing variable called largest found. Its depth can be 0. Go ahead and add that as an input. And we're going to leave this value at 0 because as the orange particle sorts through all the blue particles that it finds, we want at least the first one that it finds to be bigger than the size that we've got here. So this really just acts as an initializing variable. Otherwise, when we try to do a comparison for the first time, the value might be undefined. And undefined does not process, so that's going to prevent everything from working. This kind of sucks. So let's do this. So now we're going to iterate through memory, and what we're going to do is we will access the particle size for this particle. Let's get particle data. So the found PID, let's access its size. And let's also do this. Let's say I need to access what is the largest particle I've found so far for this particle. Now this is a single value, so it does not need to go through iterator. Now, we might need to control this on input with iterator, but we're going to wait and see if we need to do that. It's usually better to wait and see if it's working already without it before we try to exert too much control over it. Okay, so we're going to need a kind of a comparison now to compare, hey, what's the largest I've found so far with what's the size I've got in this particle at this specific depth right now. So we're going to set up we've got a comparison black box, conditions. We'll say, greater of. So what greater of does, it's just an expression that says, it's got two scalar inputs and a scalar output. And it says, if A is greater than B, then A is greater, so output A. Otherwise, if A is not greater than B, output B. So we're just going to get the larger of the two values, whichever it is. Although, this may not be what we want, because we actually want to know, hey, what's the largest size, but also which particle is it? So let's actually do this. We'll take the largest, I don't think we want greater of. Sorry about that. We want greater than. So we'll say if, and actually we'll turn these around like this. So if the particle I just found and looking at, if that is greater than the largest one I've found so far, then I want to do something else. I want to go ahead and store in memory for the red or the orange particle. I want to store. We're going to make another variable there called. We'll call it largest target, because it's going to be our target particle. So let it become our input. So if the particle, the orange particle, whoever he's looking at in memory right now at this iteration number depth, if its size is bigger than the largest one I found so far, then go ahead and turn on this memory and store that largest particle. But also store that largest size value so that we can compare it correctly next time. Now, this is not very well named. Largest size found would be better. So let's do that. So largest size found now is going to be receiving there. Okay. And then we're going to need one more rule after that. So finally, once all that iterating is done, we can have the orange particle again at birth. I know that gets a little redundant sometimes, but such is life. Look up and find my largest target, and in this case we will use that generator and create a particle at that position. Now let's give it a lifespan of say 5. No speed. Well, it's got one picked out already. I wonder if that's the one. Let's make it a little more obvious. Let's go ahead and enter our size. Unfortunately, there's no random seed on the size, but we can do it on the generator. Okay, so let's take a look at the logic. We'll do a debug and see what's happening. You gotta love debug. It is the best way to troubleshoot whatever it is you've got going on, so that we can see the actual data that's getting processed. Okay, so we iterate through the memory, the orange particle at birth. He knows how many he found in that previous look around step, feeds that into iterator. Iterator goes through all of the particles that it found, takes that particle that it's looking at that certain iteration at that depth, says, hey, what's my size? Compare that against the largest size I've found so far. If the new size that I've got right now with this particle I'm looking at is bigger than, if it's greater than the largest size, then this is true. And so this memory where I store the largest, we'll call this largest target particle. We'll call it largest particle found, just to be truly good naming. So if this one I'm looking at right now in this iteration of the depth of my memory, of all the particles I found in memory, is the biggest, then store both that particle and its size. Okay, so let's turn on debug. Enough of that blabbering. Let's go ahead and say, yeah, let's turn on largest file. Okay, well, I don't see any values larger than 10.5. Curious to see if our count is actually, so 116. So what must be happening? Let's actually do this, because we've got 116 particles that it found, but our iteration and our iterator even says it's counting through 116 times. But our output there for largest found was only 6 values. What's that mean? Well, it means first it found something that was 1.79. That was probably the first iteration number. And then we don't know how many times it iterated until it found a 5.7, which was bigger than that. Let's actually turn on this depth and size, and we'll actually see then what depth number we're looking at and what the size at that depth is. Okay, so now we get all those values. So it found 1.7938. Oh, that's the same one. 5.7. So there's the second one. Found an 8.7. And then it starts finding some smaller ones. Then it found a 10. So you can kind of see what's going on here. This is our iteration depth number, and then this is the size of the particle at that depth. And it doesn't find the largest until, I forget what the largest was. And again, this is weird here, these numbers here, it must have stored, there must be something going on with PSearch. We'll have to take a closer look at that. But anyway, this is just one way that we can kind of go through and look and kind of sort through stored memory values using Iterator and compare based on some value that we had, some variable that we've already stored and initialized up here in birth. It's important that you create this initial value, otherwise, like I said, this will come out as undefined and this will not process. So make sure you initialize your variables. And then what we do is we just go through the iteration and do a little comparison, and if we find a bigger one, then we store it. You could easily set this up to be smaller than, or the furthest distance, things like that. So we will go ahead and save this scene out. Oops, let's turn off debug. We'll save this scene out under projects, TP4 video, videos. I believe this is in the advanced topics. We're going to call this PSearch Iterate find largest. Okay, and then we'll add the prefix to that. Okay, let's move on.